Hello everybody, my name is Dima and I'm working as iOS lead here at Lanars. And today we would like to start our new technical blog, and the main motivation here is to share all our best practices that we gained over the years. What probably most noticeable and desirable is to show you really a high quality and wholesome understanding of how iOS development should be done, which is sometimes lacking over the internet. So let's start from our first series. And in the first series of our blog post, we are going to talk about side menu and various interesting tricks that can be done in SwiftUI, because as you could already notice, it differs a lot from UIKit and what we have used to before. And as you can see, the main goal here is to provide a really animated menu that can be expanded, collapsed, and it also has a switcher and a custom animation when it goes from light to dark theme, and back and forth, of course. Also, we have a selection, and probably that's pretty much it for now. And before we start, I highly recommend to go to our GitHub and download a SwiftUI drawer and basically go to one of the first commits that you will be able to find, just because it provides a lot of information over it and some sort of utility and resources that we will need over the video. And once you have downloaded our archive, I highly recommend you to switch in over to a commit called initial drawer implementation, so that you can get access to full code as mentioned above. And once your project has been switched to a commit that I recommended, in the project directory, please open the package.swift to start from something. Once that's done, please go to drawer.view and we're really ready to begin. So, as I mentioned above, we will go step by step, and let's take a little bit one more time look at what we need to do. And as you can see, the very basic component that we will start from is the drawer itself. So that's basically a container that allows our content to be presented on top of something and can be slid from edge. So let's start. Obviously, our drawer is something that represents a generic content, and let's say something will be called a menu, and the main content that is visible to the user, well, it's going to be a content itself. We obviously need to store those values, so nothing special there. Just as menu as a content as well. And one more thing we really care about is when our drawer is opened or not. And this is obviously controlled by a binding, which is one of the ways to control a state management in Swift. So let's call it isOpened, and this should be really enough. Now, of course, it's time to pass this data over in the initializer. So let's pass it as isOpened. And by the way, the reason for passing arguments in this order is to mimic the SwiftUI style, and we will get back to this later, so stay tuned. Then the next thing is to pass our menu, and this is very important to keep those arguments as view builders, so that you really make your drawer very flexible and your API looks just as any SwiftUI built-in API. So let's assign properties. Well, there is no rocket science, as you can see. The only thing that we care about here is just to invoke the view builder. Done. Let's move to body and implement really something very straightforward for the first. And obviously that's gonna be a Z-stack. And the reason for that, of course, is that the content lies below the menu. So there is only one choice, and this is Z-stack, of course. And let's align this to a leading edge. Well, simply because our content goes from the leading edge, of course. The very first layer is going to be our content, and then that's important to move at the top our menu itself. And as you already know, the view builder is very sophisticated and it allows basically any conditions to be used to construct a view, which is really neat. So let's take a look at how menu layer can be implemented. Should obviously take into account the ability to be disposed by tapping on it. So for this reason, we are going to use a clear color, just because when the menu is opened, we don't want really to overlay our content by somehow. So let's take a shot with clear color. And then on tap gesture, of course, we will toggle our isOpened flag. Or we can also set it to false, which is basically, we'll do the same here. Then it's time to put the menu itself. And SwiftUI provides really powerful view modifiers called transition, and we will just use the move from edge. And once that's done, we also need to take care of animation, because if you will try to run the code we wrote, it won't animate at all. Yeah, we have transition, but it really won't work. So let's add an animation modifier, and for the animation itself, I recommend using Spring here. Well, it's just really neat. And also animation will be invoked when the isOpened flag is changed. Basically, we can, from this point, add a preview to the drawer and take a look at what we've done before. So let's implement the preview to check out what we've done. And since we have isOpened binding, obviously there should be somebody that will maintain the state. So let's declare a view and call it actually a content view, just like we have in any example of SwiftUI app. And let's declare our state. Provide the default value, and let's add a body. And as you can see, what we actually doing here is that we are returning a drawer which uses our state as its binding, and also the menu itself, which is just a Z stack with text menu, some specified widths, and also pretty dumb content. So let's replace also the preview to be a content view. And after that, we can resume our preview and check out whether it works or not. Okay. After we launched our app in the preview, you can quickly notice, well, aside of couple animation issues that we'll fix shortly, we start from the very simple one. As you can see, tapping outside of the menu doesn't close it. And the reason for that, well, it should be in theory. But if we will take a look at our code and examine it for the correctness, we can quickly start asking ourselves like whether the clear color is actually capable of doing something. And the answer is not. It is clearly just passing touches through it. And to fix that, you may find a lot of tutorials over the internet that would suggest you to add in either opacity, to add a white color with some sort of small opacity, so that Swift would add it on top of the content and you can start getting the touches. But I think this looks like honestly like a workaround. We will go way smarter and use a content shape. And this is exactly what SwiftUI wants from us. Once that's done, let's take a look at whether our issue has been fixed. And yeah, indeed, it has been. The other thing that we need to fix before we'll move on further is that you can notice that menu is actually disappearing once we close it. Like, it doesn't look nice, and you may start wondering like, what the heck? And the reason is pretty simple, and I bet any of us who start digging into SwiftUI world has faced with it before. The thing is, once menu is going away from this view hierarchy, the Z stack actually lays it out below everything else. So just in order to show you the thing that I'm talking about is that if we will provide a smaller opacity to our content view, then you can quickly notice that our menu is still there, it just goes below the content. So how to fix it? There is a specific view modifier called zIndex. And if you will provide or even force the exact value, then ZStack will honor it and always lay it out as expected. Now, once that's done, it's really important to have an ability to interact somehow with our drawer, right? So in UIKit world, it was really easy and obvious in case you have used to it, of course, because you can simply iterate over the hierarchy, find the parent view controller, well, you know it, find the navigation view controller, the tab bar, just by going parent, 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 until you find what you're seeking for. And this was actually the way how drawers in UIKit was implemented. In SwiftUI, the world is totally different, and there is actually no way to find out who's my owner. And in order to bypass this issue, SwiftUI provides really powerful ways. One of them is to use environment, of course, or the preference keys. Each resolve its own tasks. And in SwiftUI world, that's really important to follow the same approach as Apple engineers did. And why it is so? Well, basically, if you're reusing knowledge that other developers gained over their experience with SwiftUI and other Apple frameworks, if you're following the same API approach, that basically means that any other developer that is using your code is really have some sort of expectations they're matching, which is perfect because you allow them to start interacting with your code much easier. And right now, let's take a look at how we can implement the presentation mode analog to be able to control our drawer. And we will use nearly the same approach as Apple did with their presentation mode. And the whole idea is really to be able to have a following code. When we have some sort of sibling view, either that's our menu or our content view, we will decide on that further on. And I really would like to be able to handle it and to close my menu, as well as to be able to read the current state, which is sometimes can be really useful. So let's take a look at some drop API. Let's add a new class and give it a name like a drawer presentation mode. Oops, sorry for that. Now, of course, let's import SwiftUI. That's pretty simple and doesn't have anything special. And what we really would like to have is to be able to read some sort of a flag that is called isOpened, and to be able to control it like through open and close. That's gonna make our APIs really concise and clean. And while this API looks so much different from what we have already in a drawer, and as you remember, that's just a binding to a boolean, that's still pretty easy once you start understanding that any binding can be actually mapped. And this is so powerful concept. But let's start from implementing what we have here, take into account that drawer presentation mode is going to rely on the binding a lot. And having in our mind that presentation mode is going to rely on binding, let's add an initializer that will accept this binding. How to grab it from the drawer we'll cover a little bit later. Obviously, we need to store it somewhere, so let's declare our binding here and the underscore just to mark that that's the private one. Now it's time to assign, and since the binding itself is going to be a boolean, we really need to take into account the exact binding, so it doesn't look quite nice, but still we can deal with that later. Now we can return here simply is opened value. And when it comes to opening and close, that's just setting the Boolean flag. I mean, this is pretty straightforward, except that we may skip anything, any operation in case the menu is not opened. Obviously, trying to open the menu shouldn't have any effect. So here we're just adding a small condition and saying that is opened is true, and the same applies to close. We don't really want to close a menu that is not opened. Now, it is also useful to add public modifiers to our properties and methods. Now, once the drawer presentation mode is ready, it's time to have an ability to map it from binding itself. Once you will understand the whole concept, we can really start making some real magic over our projects. But the current implementation is going to be pretty straightforward as well. Let's call it binding plus drawer presentation mode, import SwiftUI, and let's give it a try to extend the binding, where value, of course, Boolean. And let's call it mapped to drawer presentation mode. And the resulting value is going to be a binding to drawer presentation mode. And you may start wondering, okay, but how do we achieve this? And this everything comes from the initializer of the binding itself. As you can see, we can provide basically any custom getter and setter. So let's try. For the gets, we can simply return self wrapped value. Oh, I'm sorry. We can map our selves. And for the set, which follows with the new value, oops, my bad. Anyway, we will realign this a little bit shorter. But for the set, we get in a new drawer mode. And the thing is, the drawer mode is basically a wraparound the binding, so we can just treat it as open flag, and this is it. So we can do this like that. Now, as you can see, the compiler is not really happy, and the reason for that is that we have to really specify the type, otherwise it gets really nasty. So once that's done, we can build and see that everything works as expected. After we finished with binding our Boolean binding to drawer presentation mode binding, it's worth thinking, okay, but how do we pass it to our siblings? And the answer is, of course, environment keys. By using environment key, you can pass any data down the hierarchy, and then the sibling can grab it by having or using your key that you provided. And in order to implement this, we can really just add an environment key file, environment key plus drawer presentation mode, and implement everything we need. Of course, we have to import SwiftUI, but who really cares? So, whenever you would like to have your own custom values in an environment, you need to follow a prescribed procedure by Apple, and for that, let's name drawer presentation mode key, which is going to be basically an environment key. And the main requirement for this protocol is to provide a default value. And of course, in our case, that's going to be a binding. But the question is, okay, what should I provide in the default value for the binding? And the answer is, whenever we don't have any drawer that holds our content, attempting to dismiss it honestly doesn't have any logical clue. So I would suggest, how about adding just a placeholder? And the placeholder, well, that's also very simple structure. It basically does nothing rather than provides a constant value to false, which means that drawer is not opened, and for the constant binding it is impossible to change it. Therefore, if there is no drawer that holds your content, trying to close or open your drawer basically wouldn't have any effect, which is something that we would expect. So let's use just a constant API. Once that's done, we can have a constant value to a placeholder. Now, the very last bit of information that we need to provide is to extend environment values with our custom key and say it's like drawer presentation mode, which is going to hold our drawer presentation mode binding, and forget we just ask in cell for drawing presentation key, and for set we just using the same subscript but to set a new value. As you can see, nothing sophisticated over here. Now it is obviously time to use it and to pass it through our drawer. So let's go back to the drawer, and you may decide on your own whether you would like your content or only menu be able to access to drawer state. I would love to pass to all of them. So we can just set an environment key, and this is the place where we actually can finally bind our binding to is opened to a drawer. As you can see, there is no direct transition. It's all hidden in the function itself. And let's check out whether we can actually use what we read above, and we will extract this content view into a view, let's say a background view. This can be a dashboard or anything you really would like to, but for now we can just go with a background view. Let's paste our content over here, and let's try to get access to a drawer mode that we've declared above. Sorry, the drawer presentation mode. Compiler will warn us that it's impossible to compile just because the code is incomplete. As you can see, we've been using the isOpenState property directly, while now it is not available. But that's the exact reason why we developed the drawer presentation mode. You can control your drawer from any point of the sibling view. And here we can just go to drawer presentation mode and try to close it, or to open. Yeah, just because we are trying to open. Let's build and run. I hope our preview will start working. Oh, nothing is there, and that's because our content is empty. So let's just pass over our background view, and as you can see, it looks just as before, and it acts just as before. We can open and close our menu. So basically our goal is reached, and now we replicated the same presentation mode API that SwiftUI does, which is neat. Okay, I hope you're alive after we finished with the drawer implementation. But after the first step is finished, it's worth to review what we actually need to implement, just to keep it in mind. And as you can see, we finished with the drawer that moves our menu from side to side. Now it is time to focus on the menu itself, on the buttons and selection. So let's start. And since we have finished with the drawer implementation, it's worth switching to project itself, because obviously we won't fit all of the custom things like a menu into a drawer itself, because that's generic type. So click Show in Finder, and you can just open the project itself. But before, don't forget to close the preview. Let's start. And as you can see, everything is working. And after you open the example project, you can see that there are a bunch of already existing code that doesn't do that much. It just required to move on, since we won't be able to cover everything as I mentioned before. Let's review one important component that controls the way how menu is presented, which is the menu appearance. As you may remember, our menu can be collapsed and expanded, so we will just always use the menu appearance enum, which just gives us two states, the default and the compact. And another important component of the menu appearance is to be able to understand whether the view itself is in the menu, which is in compact, or the default state. And for that we have the menu appearance environment key, which mimics basically what we had before with the drawer presentation mode, so it's not really a rocket science. You may start wondering now, actually, why do we have the specific view modifier? Well, this just to make our code looks better. Just a side note, you may start wondering, okay, so how do we control this size of the menu just by having those enum? And that's a fair question. It can be possible to use something like a presentation D10 that Apple introduced recently. However, through the power of SwiftUI layout system, the child itself can counter-propose its size to the parent, and parent has to honor this size. So that's a mechanism that we will use through the app. And another important thing is the label style. In SwiftUI in general, there is a very powerful concept that allows you to extend and to customize appearance of vast majority of built-in elements, and you may name it like LabelStyle or ButtonStyle, and there are plenty of other styles as well. The whole idea that powers things up is that, for example, in LabelStyle, you're getting just a rough properties. Well, they opaque. You have no access to it, but you can define any layout that you would like to have. And you may see it as a special label style such as icon and title or icon only, and we are going to implement just nearly the same. As you can see on the labels and on the user header that we have on our list, they have a similar layout, and that's the way where we can reuse our code way better than before in UIKit, just because if you take a look at the header and the list cells, you may notice that they resemble the same layout. You can see the icon, then the spacer, and the title that goes after that. In the user header, the title itself composed of the two, like title and subtitle, which assembled further on in a VStack. But it really doesn't matter, because LabelStyle provides you access to opaque values. That being said, we can really define single style and then reuse it across our app. This opens so much possibilities for our code reuse. So as you can see, we have already implemented LabelStyle that relies on the menu appearance that we've seen before. And the whole trick here is that it offers an horizontal stack, then it lays out the icon with a exact width and height, and also the configuration title. We will cover ability to be opened and closed a little bit later, but the basic structure will remain the same. Okay, after we finished with the basic setup of menu label, I think it's worth looking at a preview. And if we will try to build and run, you can see that app fails to compile. And the reason for that is that in the content view, there is a pretty outdated signature of drawer initializer. So in order to fix this, we just may go to a drawer preview and just copy and paste. The only important part here is this bit, and we can just edit, drop the duplication, and then hide the background view, because we don't really want it to be accessible outside of this file. Now going back to the menu label style preview, we can start the preview and to check out and see that it is working as expected. That's good, but how about expanding and collapsing of the menu? As you remember, during animation, the title goes away. But here, if we will try to adjust the appearance to, let's say, be compact, the label obviously doesn't handle it in any way. And the reason for that is because we don't have any switch over here, nor any condition. So let's quickly fix this by adding check of appearance. So we may want to show a title only in case we are talking about the default appearance. Otherwise, we are going to hide it. And if you will switch appearance to a compact one and then rebuild the preview, you can see that only icon left. This is exactly what we really want to have. Now, it is time to go to a button style. And the reason for using button style is just the same as for the label style. It gives us really opportunity to extend appearance in any way we can ever think of, but we will preserve the essential behavior of the button, and well, basically button can be pressed. And you know, over the internet I saw in a bunch of tutorials and the previews that in order to handle the highlight state, people were using the long press gesture recognizers and doing other weird things. And we don't actually need to do this, because if we will take a closer look at the button style, you can see that it passes into make body some sort of configuration. Let's take a look at what this value does. And as you can see, it discloses its press state. Okay, why it does really matter? I mean, like, what's the purpose? And the thing is, in our opinion, providing a visual feedback is really important, because, you know, if user has no clue about what's going on in the app, there is basically no feedback, no way to understand whether the button is pressed or whether the progress is happening at all. So the configuration gives you this opportunity to investigate its pressed value and act accordingly. So let's go to menu label style and add one more file called MenuItemButtonStyle. And let's give it a shot. Let's import the SwiftUI and let's declare a style which will confirm to a button style. But before we will start from the body, I think it worth adding the preview. I won't actually bother you with implementing the preview because, well, that's just utility code, so I will copy and paste it, of course. And let's update our preview to return the preview view. So we can have a really fast feedback loop, a short one. And as you can see, one property came up that we haven't seen before is selected. And reason for having this property here is that in the menu, user will be able to select a menu item, and the selection remains permanent. So we need to handle this somehow. And one way to handle it in the representation is to pass this flag here. Okay, done. Now it is time to return something. I think we can just return the configuration label, just to give you like something to silence the compiler. As you can see, the preview is pretty simple and quite similar to what we had with the label preview. The only difference is that this is actually a button. So now we can add a label style here, and as you remember, throughout our extension we can use the same the same menu modifiers, the same view modifier, just as Apple do, and by that you can see that our menu label is now comes along with other built-in styles, which is still neat. Okay, so what we have here, we have a button and it has a style, but it doesn't react in any way. So let's add a reaction for this, and for that I will switch over a foreground color, and I think that color, and I think that just adding a different color when it is selected should be sufficient. Foreground. Otherwise we can just add another color, and it's going to be a colored text. You may actually inspect resources on your own. I just remember the names. Okay, let's rebuild. And as you can see, now we have a selection. Well, it remains the selected, of course, but we will fix it in a moment. The next thing is what I would like to add is the animation itself. So, just to keep our animation up to date with the rest of the app. And we'll use the Spring one, as we did before. And in this way, we will just check the difference and we will animate whether app state, whether button highlighted or selected state has been changed. Well, we in theory could add a couple of view modifiers for animation. The one for is selected and the other one for configuration is pressed. But believe me, we can just compress it to this statement and this should be sufficient enough. Now let's build and run to see whether it has anything. Oh yeah, it handles the selection. I think for now, just to check out the highlighting animation, we can comment out the selected toggle and press it. As you can see, it works. Amazing. Now, after that finished, I think we also may need to handle one more thing. As you remember, the menu is way wider than the button itself, so we would like button to be resizable. However, if we will resize it without any changes to its internal state, the label will move the text closer to the center, which is exactly not something we would like to have. So in order to handle this, we can use another modifier which gives a max width. I think we won't cover here all of the story about how SwiftUI layout works, but just believe me, by doing these kind of things, we are basically saying that the view can be resized indefinitely, which is exactly what we would like to have. A few more things need to be added here. I think that for now, just add any number and alignment, of course, leading. Okay, that's done. However, as you can see, the button itself is not tapeable. Well, it doesn't handle touches outside of the text. How do we fix it? And in order to fix this, we can use just the same approach as we did before with the clear color on the drawer. And as you remember, that's a content shape. Once that's done, you can see that the button, which is screen wide, can be highlighted even tapping outside of the text. If you will comment this out, you can quickly see the difference that pressing only the text will affect the highlighted state. However, adjusting the content shape resolves this issue. This one is important because obviously user will expect from the menu to be selectable across the whole area, not just the text or the icon. This is not something that is obvious to the user. Great. Yeah, so now once button style is finished, we can just add a few more things to make our code a little bit more maintainable. And by that I mean we need to obviously get rid of those magic numbers. Nobody loves them. So we can just declare a private extension, and let's say name it as min height, which is going to be 48. Okay, great. What's next? After we have finished those basic two components, as you remember, the whole way how to assemble the component together is to go from the very basic components to larger until we finish with our task. So now we have a layout for the label and for the button style. So I bet it's worth finally going to item list that will assemble all of those pieces together. So to add a menu list, let's go to the menu folder. Let's give it a shot and add a new menu list. Oh, sorry, menu item list. You may start wondering, like, why do we always call it menu item, menu item, menu item? And as you can see here in our menu, we have a bunch of items such as dashboard and stuff like that. So obviously it looks like an enum. And when I'm talking about the menu item, this basically, as you can see, just an enum which consists of workload, sheet, dashboard, and everything else that we have on the menu. That's just to remove some uncertainty about what the hell is this. Going back to the menu item list, yeah, we will realign. So the basic structure is that on the top we have the user header, and then we have some sort of a list, and then also a switcher that switches between light and dark mode. And the very bottom we have a button that acts like a logout or something like that. So let's start. First thing that we may think of is the list of items. So for that we can just declare a menu item. Also, as you remember from the session, as you remember before, we have ability to select items. So obviously that's going to be some sort of like a state. But I will jump a little bit forward and we'll say that we will maintain the selection above, because usually when you have those kind of menus in your application, you want to be able to understand what selection is all about. So since menu item list is more sort of a utility view, it means that it will only affect selection but won't own it. So the owner will be somewhere outside. Therefore, it has to be a binding. But remember, when you start prototyping, it doesn't really matter that much. You can just add a state and then transition to a binding further on, in case this is something that you really would like to. So we have a selection. Naming here, though, is important as well, because if you will investigate more of built-in SwiftUI components, you may quickly notice that they're using selection and stuff like that all along. And this is something that we would want to mimic as well. And the reason for that is because we allowing developers to use their knowledge that they gained over the SDK in our custom component as well. This is really essential for a good code. Now, when we have a menu, when we have an items and the selection, also there will be some sort of a user that we will render on top. And for the user, you can take a look at this structure. I mean, like, this is that simple. Just a name, position, image name, and the indicator whether user is online or not. And for the testing purpose, we're just declaring a stub with built-in values. Nothing special over here. You may have a dynamic value as well in your real production application. So since the user is going to be static and his online status will never be changed, or even if it will be, never mind, we can just declare a user here. Having this in mind, we can start adding an initializer. And as you can see, finally Xcode, hey, where is it? Oh yeah, finally Xcode gives us some neat autocompletion. The only thing is we can think of is let's provide some default values. And for the menu that's going to be a menu item all cases. And the reason for that is that the menu item is declared as case iterable, so we can just use all the available items here. For the user, the default will be of course a stop, and for the selection, Xcode gave us a wrong argument because this is going to be a binding. And well, we don't really want this to be a value with a default thing, because we want our owner to provide us some valid selection. In case we would prototype, this obviously would be a state, as I mentioned above, so we can omit this value at this during the prototyping. But for now, I will leave it as is and just go ahead with the binding. Okay, so that's done, and we can start working on the body itself. And the body itself looks like a stack, as you already could see. And on the top, we are going to use a thing called user header. I'll show you contents in a second. So as you can see, user header is basically just a label, and that's it. I mean, this is the whole power of the labels. Oh yeah, Xcode fails, and that's because we haven't finished the code in the menu item list. And also this one doesn't work, so we will just shut compiler down and we will try. Yeah, let's take a look while we're here. Going back, we declared the menu label style, and as you remember, this is really extensible thing because the label itself is generic over its icon and the title. And here, as you can see, our title is not just a text, nor it is a string. It is a vstack that can be presented or not based on the appearance. If you will try to take a look at the button, at the label itself, you can see that it works the same. Okay, well, this looks like a duplication. Anyways, we can move on and rely on this implementation, but the overall idea, I think you got it. We are resembling just the same layout as all of the buttons in our list do. Let's go back to the menu list. So at the top we're going to have a user header, and then probably I would add a spacer here just to mimic our UI and give it a height. And I already know that the height is going to be 16. And let's declare an items list. That's of course the sum view, and the view builder here is just to let us use all of the SwiftUI features that build on top of the view builders, so that we can declare basically anything in any way. So let's start from a vstack. You can go with the list, but just to keep things simple, I would really like to go with a vstack. So here that's going to be for each, because that's a for each, because we have an array of items. And then this is the neat part, because imagine in UIKit world you would declare your table view, or if you will try to mess around with UI stack view, that's going to be even worse. But for the UI table view, you would declare a specific UI cell, and then you would have to think about how to reuse the layout logic between the user header and then the cell, while in SwiftUI, by lifting those things like a LabelStyle, you can do this in a second without any issues at all. This is really amazing. I won't stop repeating that. Okay, so for the button, we can add an action. And action, obviously, whenever we select something, action will change the selected item. And for the label, we will return the proper value. So Since our logic, well, the logic from the animation, if you will try to review it one more time, the logic from animation is as follows. Whenever we select an item on the menu, if it is selected, then we want to deselect it. Well, this is some sort of expected behavior, I would say. And if it is not selected, then we would like it to be selected. So that's simple. Oh, sorry, not the nil, but the item. And then, so basically we cover in the case when we are selecting the same cell, and then otherwise we are forcing this item to be selected. Then for the label, we are going to use some sort of a shortcut that I will describe you in a second. And let's take a look. Yeah, we already can basically use the items list here. And just to remove the magic behind the label with item, it is really very easy to use extensions on the label. And when you will go through your app, you can quickly identify that a bunch of things in our UI can be described as a label, because we have a lot of things that are typed as an icon at the title. So I'm just added an extension to label that builds, that creates a label based on the item. And as you can see, this is the label that has a title as a text and icon as an image. And that's basically it. So So the only down case with our strategy of declaring the binding is that when we are talking about the previews, we need to declare some wrapper view around it. So let's just give it a shot and declare a preview view. So it will maintain the state for the selection. Sorry, menu item. And the default selection is going to be the dashboard. And also, as you remember, we can go between states of the menu, whether it's compacted or expanded. So we need to maintain this part as well, and I'll show you in a second how we can use it. Menu appearance, and let's set the default value by default. And of course, it's time to declare some body. And here we will return the menu item list that now can use our state for the selection. And I really would love to add a fixed size to it, because otherwise, if we won't have any, then view can be expanded to be a screen wide. And now we also going to pass our appearance. Now you may start wondering, oh yeah, let's check it out, whether it's work or not, whether it is working. Yeah, so as you can see, it somehow looks like our menu that we would like to have in our design. However, the button itself still doesn't have the style that we declared, so let's add it as well. And the power behind the buttons is that we can literally declare this style only here. However, since we are going to maintain the selection further on, we need to declare the button style per each button. And I will go with the menu item button style is selected. And for the selection, we can just use whether this particular button is selected. Voila! As you can see now, we have a fully working a fully working menu list, and even buttons are selectable, and we can deselect. Yeah, it doesn't look exactly like we had in the designs. However, this is a huge step forward. Next, you also notice that we are passing the appearance. And how do we control it? How about just adding some sort of workaround, since we just want to check out how menu collapses and expand itself. Let's add an action handler whenever user taps on the user header. I think that should be sufficient for our example. Let's call it like on user selected, and just going to be, this is just going to be a closure, and let's pass it here. Nothing special so far. Remember, if you are going to provide a default value, this makes your code way simpler to test and prototype. And now it is time just to add on top gesture and invoke our on user selected. Then once that's done, here we can then adjust the initializer of the menu list. And how about toggling the appearance? If we will try to run it, you can see that appearance is changing. However, it is not animated. And to fix that, we can just use with animation. This is pretty simple. So if we will wrap this around in the with animation block, and then, and then toggle the appearance within the animation, and then build and run. Okay, let's see how it works. Wow. Well, that's nearly the same as we had before. You may notice a few issues. The first one is that views are disappearing in the middle of the screen. That's the first thing. And the other one is that whenever views are appearing, they do not animate opacity. And the reason for that is actually not a bug in our code, but the issue with the previews. So in case you're facing with stuff like that, don't blame yourself all the time. Sometimes you have to. But currently here, if you will try to run this with the simulator, it will be fine. Now, I would love to check the animation as a spring one, just because it looks way better. Okay. Wow. I really love it. It starts looking just like the menu that we would like to have. Now, what else do we have left? I think it was setting the animation whenever the selection is changing, because in the future we will need it, and you will see in a few minutes. Okay, with the menu item list we're done. Now we would have to add a few more things to wrap around and to finish the very basic structure of our menu. So let's extract the background, and then just as before, we will add a menu background view, and you will see really further how we can play around with it. But my approach here is to split as much as possible to make our views as simple as possible. The background view itself, well, that's just a color, okay? So for now, I'm knowing upfront that it will be derived from the color scheme, so I'm going to pass the color scheme. Of course, we need this in the init. And then when it comes to the body itself, well, that's going to be corner radius and dimension. As I mentioned before, project already contains some bunch of utility code, so UI dimension is just an enum that gathers common constants, common UI values across the project that we need here and there, just not to duplicate those magic numbers. So I put them in the enum. Anyways, we are going to fill this with a color. And the color is called color background, surprisingly. However, if we will try to check out the color itself, you can see that it has already a custom value for a dark appearance. But as we will see further, we need to force a strict color scheme because during animation it may be glitchy. So just believe me, let's pass the color scheme to, let's just force a color scheme to a value we would like to have, because otherwise if we won't pass an environment, it will do this automatically based on the current system appearance. This is not something that we really want. Here we're just going to pass then a background and the color scheme. Well, let's leave it light for now. Let's update the preview. Oh, okay, so we are moving really close to what we had. Now, let's go back to the menu. I'm surprised that view disappears altogether. We'll fix that shortly. Now, going back to the menu, we are passing the menu appearance, so that's okay. Then also we need to have a clipped, and I really would like to have a shadow. Shadow just gives us some sort of a depth, and you will see when all of the components are tied together, you will see that having the menu on top of the content below looks better with a shadow rather than without. So we're just going to add a shadow. Color, well, this is going to be a black one with some sort of opacity, and the radius, well, like that. Those values are grabbed from the designer. And also, we don't want our menu to be glued to a leading edge, so we are adding the padding. Now, once that's done, you may notice that our menu has a width of the screen, so the full proposed size. This is not something that we want, because what I would like to have is to have a width of the largest button over there, and that all of the cells other than that would retain the same width. Like you get, we are going to size the whole view to be the width of the maximum element of it. In UIKit world, this would be a disaster, but here we can just use a fixed size view modifier. And while we are not going to dive deep into SwiftUI layout, because there are plenty of articles and tutorials that describe this way better than me, I'm just going to say that SwiftUI layout system is so much powerful, and fixed size really forces ideal size of the underlying content to be the preferred one. And the ideal size for the horizontal stack is going to be the minimum size that it should fit into. And this ideal size composed of the maximum of all of these elements. I hope that's clear or not. Probably it is not. Anyways, our menu started becoming way better than before. And now it is time to fix the disappearing button, and I figured out that here I just have a typo. Well, this is the downside of the raw strings. And if we will try, okay, now the button is green one. Moreover, in the preview, we can also trigger or force the color scheme to be dark one, just to check out how it works in the dark appearance. Okay, looks great. Looks great and amazing. Now, once that's done, we can try to assemble all of those things together, because now we have a menu and it's time to provide a content view. Okay, so then in the content view, we just need to update our drawer. And we are not going to change this open flag. However, for the menu, instead of Z stack, we are going to return our real menu. This one's done. We don't need the exact frame as before. But here we really would like to do something else instead of just the content. Let's say we are going to have some sort of a background. Of course, in the production, you don't need to have a row strings across your app. But here, since we are talking about the example, there is no reason to inject a SwiftGAN. This is going to make things even more complex. So here we just want to force the color scheme. Okay, that's not the time to do this, but what we really need is to ignore the safe area insets. And then probably this is it. And also we need a way to somehow open and close our button. Oops. So, I'm sorry, what the, okay. So then in isOpened, we are going to toggle animation. Oh, sorry, to toggle isOpen state. And for the label, they're just going to be open. And just to give it a better representation, we are going to assign a color for that and probably some style. Okay, so now it looks a bit better. Yeah, the only issue at this point is that it's really hard to distinguish the content view from the menu. Oh, my bad. So in order to fix that, we can probably switch over the color scheme. And to handle that, we can simply force the color scheme to be an inverted value. So to do this, we need to pass the exact value. And here we are going to grab the system color scheme. We'll fix it shortly, but for now, this should be sufficient. Copy and paste, and then we have a small helper function that inverts the color scheme. We can even force the whole view to have an inverted color scheme like that. This looks way better. Don't forget that, and better don't get confused, that if animation at the beginning doesn't work, it doesn't mean that something went wrong with your code. Sometimes it can be just a simulator issue, sorry, the preview one. So if we will build and run this app on the simulator, you will be able to see that animation works as expected. So let's give it a try. Okay, so let's build and run. And as you can see, the colors are not exactly what we would like to have. And the reason for that is because I believe for me that's already a night outside. And if we will go here in the menu view, the last bit that we need to fix is to set the proper color scheme. Because as you remember, we have set it to light one, and here we really need to set the system one color scheme. So we will do just the same, system color scheme, and set the system color scheme. Now let's rerun. Okay, this looks awesome. Okay, I hope you enjoyed the first part of our blog, and stay tuned because we will roll out the second part shortly, and they're really the most interesting thing of our side menu. That includes some nasty stuff with masks, with SwiftUI animations, and we will implement even custom transitions, those that you could see like opacity and move to various edges. We will implement actually the same but our own. And not limited to the side menu, we still have a lot of topics to share with you. So I hope you enjoy our journey. Stay tuned. Bye.